Welcome to doassignment-ca. Here is the problem. A two-stage rocket is fired vertically from rest. In phase 1, from time 0 to 15 seconds, the acceleration increases linearly from 0 to 15 meters per second squared, so a of t equals t. In phase 2, from 15 to 40 seconds, the acceleration is constant at 20 meters per second squared. The initial velocity and initial position are both 0. Derive and plot the velocity time and position time graphs for time from 0 to 40 seconds. Now, let us work through the solution step by step. Looking at the acceleration time graph, we identify two phases. In phase 1, from time 0 to 15 seconds, the acceleration rises linearly from 0 to 15 meters per second squared, giving us a of t equals t. In phase 2, from 15 to 40 seconds, the acceleration is constant at 20 meters per second squared. The rocket starts from rest, so both initial velocity and initial position are 0. To find velocity in phase 1, we integrate the acceleration. Starting from rest, the velocity equals the integral of t, which gives t squared over 2. At t equals 15 seconds, the velocity reaches 225 divided by 2, which is 112.5 meters per second. This becomes the initial velocity when the second stage ignites. Integrating the phase 1 velocity, the position equals t cubed over 6. At t equals 15 seconds, the rocket has traveled 375 divided by 6, which is 562.5 meters. This is where the second stage begins its burn. In phase 2, the acceleration is constant at 20 meters per second squared. Using the kinematic equation, velocity equals 112.5 plus 20 times the quantity t minus 15, which simplifies to 20t minus 187.5 meters per second. At t equals 40 seconds, the velocity reaches 612.5 meters per second. For position in phase 2, we apply the constant acceleration kinematic equation, starting from 562.5 meters, with an initial velocity of 112.5 meters per second. The position equals 562.5 plus 112.5 times the quantity t minus 15, plus 10 times the quantity t minus 15 squared. At t equals 40 seconds, substituting 25 for t minus 15 gives 562.5 plus 208.12.5 plus 62.50, which totals 9,625 meters. Here are the complete piecewise equations. The velocity equals t squared over 2 for the first phase and 20t minus 187.5 for the second phase. The position equals t cubed over 6 for the first phase and 562.5 plus 112.5 times t minus 15 plus 10 times t minus 15 squared for the second phase. Key values are velocity 0 at time 0, 112.5 meters per second at 15 seconds, and 612.5 meters per second at 40 seconds. Position 0 at time 0, 562.5 meters at 15 seconds, and 9,625 meters at 40 seconds. Looking at the graph shapes, the velocity time graph shows a parabolic curve from 0 to 15 seconds because acceleration is proportional to time, then transitions to a straight line with a constant slope of 20 from 15 to 40 seconds. The position time graph shows a cubic curve in the first phase and a parabola in the second phase. Both graphs show a distinct change in curvature at t equals 15 seconds, which reflects the jump in acceleration when the second stage ignites. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.